Hi, welcome to your video on comparing and ordering rational numbers. Your I can statement is I can compare and order rational numbers by using equivalent representations. Just a quick reminder for you about negatives and fractions. Here I have 4 different examples of negative numbers, negative fractions. The first one is the negative sign out front. The second one is the negative sign in the numerator. The third one's in the negative in the denominator. These 3 are all equivalents, okay? They're the same thing. They all mean the same. Your fraction is negative. However, though, this one is different. This one actually ends up being positive because a negative divided by a negative is a positive. Second reminder for you, how do I find equivalent fractions? When you have a fraction and you're trying to find an equivalent, you get to pick what you scale it up by, what you're multiplying by. So I can multiply by 2, and then I would get 2/4. I can take the same thing, the original 1/2, and multiply it by 4. Okay, and then I would get 4/8. I could pick the same thing and multiply by 10. And I would get 10/20. You can pick whatever you want to multiply by, but make sure you always go back to that original. Same thing is true with negatives. Okay, I can multiply by 2, and I would get -8/10. I could multiply by 3, and I would get -12/15. And I could multiply by 7. And I would get -28/35. It doesn't matter, but just a quick review for you. All right, how do I compare rational numbers? This is the most important part. When you're given 2 numbers to compare, sometimes they may be positive, sometimes negative, but their chances are they're not going to be the same. One might be a decimal and a fraction, like example 1 here. What you want to do is change the form so that they're both the same. So in this problem, I'm going to change this to -3.5, and then I'm going to change this one and convert it into a mixed number also. And that would give me 3.5, and it's negative, so -3.5. So when I compare these actually end up being equal. Second one here. Okay, -1 and 3/10 and -1 and 9/10. Now, if you think about a number line, okay, and here's 0 over here, -1, -2. Okay, -3 and 1/10 is a little closer to the -1 side, so it's going to be kind of over here, approximating. -1 and 9/10 is almost -2, which means it's going to be closer over here. So which one's bigger? That's going to be the one closest to, or the farthest right, which ends up being this one over here. So 2 dots is the one that points to the larger number, and there's our greater than sign. Last one here, a decimal and a fraction. What you'll want to do is either convert them both to fractions or both to decimals to compare them. This one I could take and say this 125 thousandths, and then I can simplify this down. Find your GCF, simplify it. It ends up being 1/8. Okay, so now I'm comparing 1/8 and 1/6. Now you might know what it is from there, but chances are you might want to take it one step further, and that would be to find a common denominator. And in this case, we can use 24. 8 times 3 is 24, so I have 3/24. 6 times 4 is 24, so I have 4/24. Which one is bigger? Ends up being the 1/6. Just sidestep here for a second. You could have taken 1 and divided it by 6 in your calculator. You would have gotten 0.16 repeating. That would have been probably faster, but you can go either way. How do I order rational numbers? You'll want to use a number line. Here's example number 1 for you. is we have 1/2, -8/10, 1, and -0.2. So you'll want to change them all to either fractions or all to decimals. It doesn't matter to me. If you choose fractions, though, make sure they also end up having a common denominator. So here we go. I'm going to change them all to fractions. So this 1/2, we want common denominators. So I'm going to change this to 5/10. -8/10 can stay. 1 can stay, because that's easy. And then -2/10 is how I say it. So here's my -2/10. Now I can plot all these. 5/10 is going to be right there. -8/10 is pretty close to -1. And then 1 is here. And then -2/10 is pretty close to the 0. So now that I have all of those, I know this is kind of hard to read, but you can kind of see where all of these end up going. It might make it a little bit easier for you to put them in order. But then from least to greatest, the smallest number is going to be the farthest left, which ends up being the -8/10. So that's the smallest one. Next up then is going to be our -2/10. Then we have our 1/2, and then we have our 1/2. Second example for you, -1/5, -4/10, -2, and 9/10. Again, you can choose to put them all as decimals or all as fractions. It doesn't matter. I personally kind of like working with fractions better, and so I'm going to make these all have a common denominator. There's 9/10. That's easy. -2 is going to stay -2. -4/10 is going to stay -4/10. And -1/5, I'm going to change it to have a denominator of 10, which will give me then -2/10. And I can plot all of these relatively easily. -2/10 is pretty close to 0, so that one's going there. Then -4/10 is actually even more like -1/2, so that one's a little bit farther to the left. -2 is an easy one, that one's going right there. And then 9/10 is positive, pretty close to 1, so that one's going there. So now when I put them in order, I just go from least to greatest. The least number would be -2, and then I have these ones, and the greatest one is 0.9. Alright, your turn. Number 1, compare them. Number 2, order from least to greatest, and that's -4.8. It looks kind of sloppy. Make sure you're converting either all to decimals or all to fractions of common denominators. Go ahead and turn on your video when you are done. Alright, here are the answers. Make sure you mark on your paper which ones you got right, which ones you got wrong. If you do have questions, now would be the time to ask. This is the end of your video. Thanks for watching. Have a wonderful day.